Hi, it's Dave Dugal, founder and CEO of EnterpriseWeb. I'm joined today by Bill Malik, our Chief System Architect. Bill and I are both excited to share with you the premiere of an industry-first telco-grade generative AI for intent-based orchestration demo. The beautiful thing about this presentation is, since it's based on natural language programming, is that you're going to see a very rich interactive conversation with generative AI that is powerful on its face. However, I do want to give you a little bit of setup so you know what we're doing, how we're doing it, and what the use case is for the demo. So let me move on. So first I want to share with you a quote, and I won't read it to you, but it really just sets up that for every big advance on the analytics side, it always has to be matched with an advance on the middleware side. That these two have always gone together, both the sort of analytics, the probabilistic, Bayesian statistical side, what used to be called OLAP, online analytics processing, and the deterministic rules-based transactional side. And these things go together hand in hand, essentially two sides of the coin. Enterprise Web is facilitating generative AI in the sense that we've reinvented middleware. So now you're talking about the best-in-class, state-of-the-art analytics capabilities meeting the best-in-class, state-of-the-art automation capabilities. So we've reinvented middleware from the static, tightly coupled, vertically integrated stacks that you're probably familiar with, that sort of inhibit interoperability and change, to a dynamic, loosely coupled, horizontally architected platform. Enterprise Web is cloud native, serverless, 50 megabytes, and it requires no stack. So there's no third-party queues, gateways, brokers, integration tools, orchestrators, workflow engines, etc. Those components that many of you who are charged or tasked with implementing these kind of solutions are familiar with. We don't need any of them. We provide them with a serverless solution that I'll detail on the next slide that's completely horizontally architected. So the idea here is that you have now a common solution, sort of holistic, that you can deploy to any environment at the core, at the edge, on a device, and give a consistent developer experience and sort of rationalize your solution architecture. And what Enterprise Web is providing in this context is a serverless backend for generative AI, which is pretty exciting. So what does Enterprise Web really boil down to? You can think of it as a catalog of stateless functions representing middleware capabilities. So instead of that stack that was tightly coupled, wired together in advance, and then you hard-coded your solution on top of that, and if any element changed, any one of the components changed, or your business logic changed, you could break something else down the line. Here, we're actually doing everything as stateless functions. And those stateless functions are efficiently hydrated for global context by a knowledge graph, right? So the knowledge graph has sort of the domain knowledge. It understands what the business users are looking to do. It understands the rules of the domain. It understands the objects of the domain. And then it has the capabilities that implement the behavior that the business wants. So at runtime, the system's taking requests and events. The graph model is imposing or providing context and constraints or controls. And the output is personalized user experiences, optimized transactions, and synchronized operations. All of this in 50 megabytes. Again, a common technology foundation that you could distribute anywhere for any use case in any vertical, not just telco. So for today's presentation, the solution involves a couple of partners, right? So on one side, we're working with publicly available generative AI technologies, Jarvis for natural language programming, OpenAI, which is a well-known generative AI foundational model. We're using our partner KX, which provides a high-speed analytics database. And you can see they're between Jarvis, the generative AI, and Enterprise Web for the automation capability. So they're providing a role as sort of an intermediary, keeping a sort of arm's-length relationship between sort of that conversational analytics side and sort of that deterministic automation side. And then we're showing Power Apps here as an example of a front end that Enterprise Web could be working with. Now, we could be working with any front end, including a custom front end that a customer has. Um, in this case, it's just we're going to create some stubs and show that the integration could be done with Power Apps, so that people know that that's a capability. Otherwise, Enterprise Web can also act as the front end. So drilling down a little bit deeper, sort of generative AI, for those in the know, is sort of an outcrop or a development from deep learning models, right? Neural networks. It's prompt-based query language, statistical reasoning, right? So it's looking at vast data sets and then analyzing those data sets to come up with uh, probabilistic statistical results. KX, as I mentioned, sort of a vector native time series database. It's an analytics database. It has a temporal query language there. It's bringing order and sort of local persistence to the work we're doing with Jarvis and OpenAI. It's supporting real-time stream processing, predictive analytics, and again, it acts as a sort of local intermediary, which is a sort of an important role because you don't really want sort of this unstructured, unlabeled, unsupervised responses from Jarvis to flow directly into your automation systems, because your automation systems have to be concerned with safety of processes, business compliance, IT governance, as well as physical safety when they're working in IoT or industrial settings, et cetera. So yeah, you want an arm's length separation there. Enterprise Web is effectively a realization of symbolic AI, or the old school AI, rules-based query and transformation language. It's just a modern implementation of the original ideas of AI, now in a fully distributed context with a serverless backend. And once again, Power Apps is the front end. Now, what's really interesting here is together, taking the neural network type technology and the symbolic AI, we're achieving something that's known in computer science as neurosymbolic AI, and it really doesn't exist outside Enterprise Web. We're achieving a realization of that together here in this demo. So that's going to give us this conversational interface, which you're going to see is very quick, very fast. That gives us a contextualized and controlled behavior that the enterprise or the telcos absolutely need. So going into the demo script, what we're actually going to demonstrate today, what Bill is going to demonstrate, I'm going to pass the baton to him, is a generative AI for intent-based orchestration, right? So Bill is going to show you, he's going to have a conversation with Jarvis, and it's going to be composing, configuring, deploying, and managing a network service, right? Things that are pretty complex, difficult and time-consuming even for a network systems engineer, and we're going to do this in minutes. Right? We're going to take this very informal conversation, we're going to translate it into something very real world, industrial grade. KX is going to act as that added value intermediary behind the scenes. It's going to allow the developer to informally express his intent, right? And that's a sort of very area of interest in telecom right now, intent-based programming, right? And here we have a very rich notion of intent, which is going to be translated through Enterprise Web into domain-specific queries and commands. Enterprise Web is effectively providing the context, the capabilities, and the controls for intelligent and safe telco-grade automation. Power Apps is going to be front end for catalogs, orders, and inventory. We're actually going to do that in Enterprise Web today. We're just going to show you that we can generate the stubs. Enterprise Web is the back end, handling all the implementation details, along with the non-functional concerns. And when I mean non-functional concerns, I'm talking about things like reliable messaging, that includes immutability, item potency, etc. It also includes transactional guarantees, retries, compensations, etc., as well as state management, local persistence, indexing, tagging, etc. That all gets done in the same dynamic control flows. The developer doesn't have to worry about it. So at the service level, Enterprise Web and KX are also implemented as part of the network service itself. We're going to be deployed as a service-based SON, where KX is going to be observing the environment, Enterprise Web is going to be reacting to the events and pushing down mediation so that we can essentially self-scale, self-heal, and self-optimize the environment. So collectively, this demonstration, which we're going to do in a few minutes, 5, 6 minutes, we're going to actually show you through an informal conversation, day 0, day 1, and day 2 behavior, all through natural language. So to give you an idea of what this is going to look like, and Bill's going to do it for real, but just to summarize it, Bill's going to say something like, compose a secure 5G gateway. It's going to literally be that easy. The system is going to generate a 5G gateway, right? It's the domain model sort of understands the concepts and the components and the relationships between those components and the rules that applies. It understands the 3GPP. It understands O-RAN concepts. It understands what a firewall is, what a SD-WAN is, etc. And it's going to build out a service. And in this particular presentation, it's involving components from a variety of our partners and colleagues. So Bill's also going to declare and maintain intent, again, conversationally. So he's going to say, something like optimize for energy efficiency. That's a pretty high-level statement. But the system, it's almost like, as you can see, as I depicted here, like an equalizer, right? And KX is going to observe the deployment environment, and EnterpriseWeb is going to automate the mediations. So at runtime, or essentially during day 2 operations, you're going to have a self-optimizing closed-loop autonomic behavior. It's constantly optimizing the environment based on the declared SLAs, SLOs of the service designer or customer. So that's it. Hey, Bill, I'm going to pass it to you for the demo.
Okay, thanks, Dave. Now I'm going to log into EnterpriseWeb, and I'm going to have a conversation with Jarvis to compose, deploy, and manage a new network service. Execute command, create a secure edge gateway for web conferencing using open source called Demo Service 1.
To do this, I will create a new network service template named Demo Service 1. Add an instance of EtherStack for RAN and Core. Add an instance of FreeFW to act as a firewall, SD-WAN provider. Add EnterpriseWeb SMO for RAN management and add EnterpriseWeb NSSMF for core management. Would you like me to proceed?
Yes.
Okay, working on it. Service template created.
Okay, that's a good starting point. We're going to make a few enhancements now. Execute command, upgrade to licensed components.
To do this, I will replace FreeFW with Fortinet FortiGate to act as a firewall, SD-WAN provider. Configure firewall to secure the control plane for EtherStack, which is a new available feature. And please note, only some components can be upgraded because no commercial alternatives are available. Would you like me to proceed?
Yes.
Okay, working on it. Network service template updated. Also, it is recommended to add an application firewall, a commercial component which is now available because the restriction of open source only has been removed. Would you like me to do that?
Yes.
Okay, working on it. Network service template updated.
Okay, we're going to add some optimizations now. Execute command, add a SON.
To do this, I will add self-optimizing network to network service template. Add KX instance for self-optimizing network to network service template, and then I will prompt you to specify the intent of the self-optimizing network. Would you like me to proceed?
Yes.
Okay, working on it. Adding self-optimizing network. Would you like the self-optimizing network to optimize for low latency, energy efficiency, or low resource consumption?
Optimize for energy efficiency of the service overall.
To do this, I will set intent to optimize energy efficiency and configure all components so that the self-optimizing network will maximize energy efficiency of the service. Would you like me to proceed?
Yes.
Okay, working on it. Optimizing network service for low latency.
Okay, now I could drive into the components and take a quick look and see that it set the high level intent there for efficiency. And if I want to go into any of the actual functions, I can even look at the policies and constraints it put in place to realize that intent. Now I'm pretty happy with my service, so I'm going to move on to integrations. We wanted to show how we could integrate with any front end, such as Microsoft Power Apps. We don't have a public API for that though, so I'm just going to generate some stubs just to show you how easy that actually is. Execute command, generate bindings for Microsoft Power Apps.
To do this, I will synthesize a REST endpoint to deploy instances of the service. Generate Power Apps appropriate bindings and export as a Postman collection. Would you like me to proceed?
Yes.
Okay, working on it. Network service template updated, bindings added for Power Apps.
Okay, so the bindings are right there, and if we wanted to, we could examine them, a little bit closer. That's enough for us to build an integration between the two systems. Now I'm just going to proceed to deploy this service. Execute command, deploy an instance.
To do this, I will deploy via LCM operation, instantiate. Would you like me to proceed?
Yes.
Okay, working on it. Network service instance is being deployed.
Okay, now if we were to jump into OpenShift here, we could actually see the pods and deployments as they're coming up. And if we jump back into EnterpriseWeb in a couple of seconds here, we'll see that the service will actually be deployed. There it is, it's active. And if we wanted to, we could jump into the low-level details. We have a trace of all the many operations that were needed to realize and deploy this service and then optimize it. Okay, thank you very much. Back to you, Dave.
Great. Great job, Bill. Thank you so much. So what I want to do now is recap. I think hopefully that was clear again on its face. I want to just drive back down into some of the details that are sort of hidden behind that sort of easy, informal conversation. So first, Enterprise Web's graph domain model is providing declarative semantics for an informal and concise conversation with generative AI, right? Contextualized, typed, and managed. That's non-trivial. That's something that's, these using graph models that are being essentially through KX as an intermediary. Generative AI is essentially walking our graphs and introspecting indirectly, walking our graphs and introspecting our catalogs, and that's what's allowing these compositions to happen. It's replacing what would be thousands of prompts, right? Complex prompt engineering, while extending the capabilities and improving the outcomes, right? Because actually, it's much more efficient to do this with rules-based programming. Efficient, more reliable, and traceable, right? There's a lot of reasons why you'd want this, right? Enterprise Web itself is a no-code platform, fully declarative. It enables intent-based automation, right? So translating between the sort of developers' requests through generative AI of what to do, and then Enterprise Web is independently handling the how, right? The implementation side through a model-based event-driven policy-controlled process, right? The LLM is invoking Enterprise Web, but it doesn't know our methods or control our implementation. Once again, that's about safety and security. Enterprise Web uses its graph domain model to configure the KX analytics database as a local translator with generative AI. Really important, that word local, right? We're not doing this necessarily in the cloud. We could do this at the edge. We could do this at the core. We could do this anywhere effectively, and it's data that's running in the customer's environments, right? And we're also the training is happening in the customer's environments, right? We're not training the LLM directly. We're protecting the customer's IP. This is the whole point of, the name Enterprise Web is about being enterprise grade web scale. These are the things that motivate us. So we're constantly thinking about those concerns. All right, so Enterprise Web has a single click capability. So we take our graph domain models, and remember, that's not just telco, it's for any domain, right? So we model domains within days or weeks, depending on how complex they are. We do that in a semi-automated fashion where you can import RDFs, XML, JSON files, whatever. Then we project those into a graph, map them into our models using algorithmic entity extraction and mapping, etc. And we then, with KX, we essentially have a single-click export for local vector embeddings, right? The embeddings are not going into the LLM. The LLM has no direct contact with Enterprise Web, right? We're doing it in KX. And then KX is doing the translation between us. Enterprise Web configures KX Analytics database for sophisticated model-based subscriptions. So this is actually AI ops, right? So instead of just giving us sort of this unfiltered stream, KX is actually doing work on its side to translate from the neural net language, large language models, the vector-based language of the LLM, generative AI, into the symbolic language of enterprise web, right? So that's allowing it to sort of interpret, filter, and translate into the queries and commands that enterprise web understands. It's also eliminating the need for complex prompt engineering, right? You don't have to do that in advance anymore. You just, once you have the model, not only does that model serve you in enterprise web for whatever you're doing in enterprise web for automation, it now automatically applies to whatever you want to do with generative AI. So that kind of reuse is super powerful. Essentially, it's a common interface, right? A common API interface for both for your developers as well as your generative AI or high-level analytic systems. So we can, if the customer wants, if they give it the permissions, can expose business outcomes, right? I'm not talking about the data. I'm not talking about the model. I'm not talking about the details. I'm talking about summarized business outcomes with KX, which KX can then further share as summarized training data for LLM. So now, previously, in the last line, we were talking about AI ops. Now we're talking about ML ops to enrich subsequent conversations. Again, arm's length with generative AI, and that's sort of a controlled tuning of the large language model. And now you got KX and Enterprise Web running local on standard x86 chips with no specialized, chips for and running on x86. We're already providing high performance, low latency, energy efficient performance, right? And we're essentially, by offloading it locally, we're minimizing the expensive LLM interactions. I mean, that's not only a money question or a money advantage. That's you just think about the energy, the resources, the water cooling, the electric power that is required to do generative AI. You'll realize that's simply not practical. And I'd argue actually it's not smart or good to use generative AI to do your actual automation, right? Because the cost will go through the roof. And since it's only probabilistic, it's never going to give you the kind of control, security, and safety that a rules-based, logic-based system is going to give you. So I'm going to leave you with one last thought. So obviously, generative AI is well known for code generation, just as it can generate artwork or music or anything else like that. But at that level, it's sort of like an entry-level assistant. And that's getting better, of course, but it's still imperative code, right? That's giving you essentially stubs or essentially boilerplate code that you then cut and paste into something, right? And then you do a build and compile and you do all that, right? It's not changing the nature of development. And I think that's a mistake, right? It wouldn't be recognizing what a generative AI is a major leap in analytics. And its really highest and best purpose is that conversation, right? It's the ability to raise intent to an informal conversation. This is what's going to change the world. So in a recent blog post, and there's a link to it right there, I just note that, all forms of AI, not just generative AI, really favor, model-based dynamic systems. Why? Because those systems were born to react to interaction context. And isn't that the whole point of being responsive and real-time data driven? So the link is there. This PDF will be shared. And so you can click on that, or you can just go to the Enterprise Web website and retrieve that blog post. So with that, I just want to say thank you so much again for attending the premiere of our industry first telco grade generative AI for intent-based orchestration demo. Thank you and have a great day.